Everybody take notes.
Okay, so today
Get your notebook out.
we are going to do slope-intercept form. Slope-intercept form is the most important shortcut that we are going to look at. Okay, so if you have to only pick one out of the three that we're going to look at to know, this is the most important one.
And the hardest.
No, it's easy. And none of them are hard.
Yesterday?
Yes.
It wasn't even hard.
In fact, today is probably easier than yesterday in a lot of ways. Okay, I promise, these are all super simple. Nothing about anything we're doing is hard. The tricky part is when you have them all mixed together and getting them confused. Okay, so standard form on its own is simple. Slope-intercept form on its own is simple. But if you have one standard form and then one slope-intercept form and then going back and forth, making sure your brain remembers what you do in each situation, that's the trickier piece. Okay? So, slope-intercept form, just like yesterday, has a general form. Its general form is the one that my students all know. Y equals mx plus b. Case, I need you to please sit down. Headphones need to be out. No one headphones out. Just stop. Okay, y equals mx plus b. Okay, just like we said yesterday, there are two things we can find in standard form. There are two things we can find in slope-intercept form. Slope-intercept form was not creatively named. So the two things that we can find in slope-intercept form are a slope and an intercept.
Y-intercept.
In this case, it is the y-intercept. Okay, we have already learned that the letter for slope is m.
Oh yeah.
The letter that we use for the y-intercept is b. So if we look in this general form, we'll see that we actually have the letter M and B sitting in it. So yesterday we had to do a small, though very simple amount of math to find our two things. Today requires no math at all to find them. We just look with our eyeballs and we see them. Okay, the important piece to know is that the M is always what's sitting in front of X. The B is always the one that's not sitting with the X. So even if those orders were to be flip-flopped, our slope always has the X by it. So if we have something like y equals 2x plus 4. If we want to find our slope and our y-intercept, we are just looking to see what number is sitting in the correct location. Okay, so our slope is whatever's sitting with x. So our slope, or our m,
2.
is going to be 2. Thank you. Our b, or our y-intercept, is whatever number is sitting by itself. So what number is by itself?
4.
4. So our b is 4. And that's basically all there is to it, but there's a couple things we might need to make sure we're okay with. Okay, so y equals 1/2 x minus 3. what's in front of the x. So, right, that's going to be our 1/2. What's our b going to be on this one?
-3.
-3, right? Because that subtraction tells us that it's negative. No, new color. What if I had y equals 2x? Okay, so what does my m equal?
2.
2. What does my b equal? 0. Okay, because we're really adding on nothing?
Why wouldn't it just be no solution?
A no solution is something that doesn't exist. Okay, and there is a value being added here, we just don't need to write it. Okay, so very similar, I guess, maybe if we would say, I guess we would see it like this, right? We would see y equals x plus 4, right? We don't see a value sitting here,
1.
but we know that the value sitting there is 1, right? So that's the same idea that's happening over here. This would be an m equals 1 and a b equals 4. Okay, how about if we have y equals 3? What would m equal?
No slope.
0.
Yeah, 0 would be the better.
For an interruption, can you please send Alberto Torres to the front office for early dismissal?
I will send him.
Thank you.
Okay, so our m is going to be 0 because we don't see anything there with the x, right? So this is going to be y equals 0x plus 3. We see no x's, so our slope is 0. What would our b equal?
3.
3. Okay, so we're just identifying m and b, no math involved in finding them, just what's sitting in the right location. Okay. Then just like we said with standard form, we can take that information and we can turn it into a graph. So last week when I checked notebooks, we did a terrible job at putting anything in our notebook that was pertaining to graphing.
No.
Okay, so I want you to put one example in your notebook, and then I'm going to let you use board marker and eraser if you want to instead. But I at least want you practicing these with me. So draw a graph, even if it's totally generic. Give yourself something. Make an x and y axis, a vertical and horizontal line.
No.
The most perfect square. Okay, so let's say we want to graph something like y equals 2/3 x plus 1. Okay, if we want to graph this, our first objective is going to be what we were just doing. We need to find the slope and we need to find the y-intercept. So what is our m going to equal in this problem?
2/3.
2/3. What is our b going to equal in this problem?
1.
1. Okay. Once we identify those two things, the first thing that we want to put on our coordinate plane is going to be our b. So my students will often forget alphabetical order. Your b goes first. Your y-intercept goes first. So you're going to plot b on your y-axis. Okay, remembering that your y-axis, is that one running out?
Oh, there it goes again.
Your y-axis is your vertical axis. Okay, so we're going to go to 1 on our y-axis. This is a big mistake for my students. I mean, when we plot points, we always move horizontally first, so it seems like that should be what we do first, but it's not. Okay, B is our y-intercept, so we're going to go on our y-axis. Judith. Our second step is that we are then going to count
Up 2/3.
from that point. Not from the origin, not from anywhere else. Okay, we're going to count our rise and then our run. Okay, keeping in mind that rise and run are from our slope, right? So this is our rise, and this is our run. So from this point, we want to rise to. What direction does rise tell us to do?
Up.
Up to.
Over 3.
What direction does run tell us to do?
Right. Or left.
Right, because it's positive, so then right 3. Now, whether you had myself or anyone else, and when you were doing graphing before, we said 3 points, 3 points, 3 points, 3 points. Okay, you don't actually have to have 3 points to make a line. The reason why we said 3 points was to make sure that if you counted wrong, you would catch your mistake. Okay, so I always think it's a good idea to count one more time, to go up 2, right 3. That way, if you get a third point and it doesn't look like a line, you can be like, ooh, I must have counted like up 2 and over 4 on accident. Especially on the screens in Alex, it's a little bit easy to sort of miscount. Okay, so really make sure you're not miscounting. If you're only going to make 2 points, I'd just double check. Make sure that's where you want that point to be. Okay, so then I will then leave the next decision up to you. You can either continue writing in your notes, or you can get out your board marker and eraser and be looking at your graphing side. But I still want you following along with what we're doing, so you're practicing these same concepts I need you to see. Okay, so let's say we want to graph y equals 3x minus 5.
3/1.
Okay. So we said the first thing that we would need to do is we would need to identify our m and our b. So what does our m equal?
3.
3. What does our b equal?
-5.
-5. Okay, so the first thing that we are going to do is we are going to plot -5 on the y-axis. Right, so on our y-axis, let's make a point at -5. Okay, then from that point, we need to count our rise over our run, but we have this problem. This isn't a rise over run format. How do I make 3 a fraction, Bryson?
Put it over 1.
Right? I can just make 3 a fraction by putting it over 1. Okay, that then takes care of our run piece, so now we can go up 3 over 1, right 1. Right, if we count twice, just to make sure we have that counted all correctly, here's what we get.
Oh, you're up.
So I want you to graph this one on your own. Y vary from distance.
No.
You know what?
What?
206. 206.
So that looked good going around the room. So we're here.
Yeah.
Okay, so I want you to graph y equals 4x. So what does our m equal?
4/1.
4/1. What does our b equal?
0.
0. Yeah, but just still make that 0, that point you're starting from. Yeah, that's all I was looking for. So if we don't see anything, we just have to see 4. So we're gonna start at 0 and go up from. Okay, so we're good there? Okay, then let's look at what happens if we have a negative slope. And this is the piece that my students struggle with the most, because somehow they have made up strange rules about what negatives mean. Okay, so let's say we have y equals negative 5/2 x plus 3. My students have no problem identifying what m and b is. Okay, so they're happy to tell me that m is negative 5/2. And they're happy to tell me that b equals 3. Where does that negative go? Does that negative go to the 5, to the 2, or to both?
Both. The 5.
Both.
It's the 5.
It goes to 5.
It goes as a whole.
Okay,
It goes to 5.
It goes to 5.
this
Logical.
is the same as this, but it's also the same as this.
So it's a whole.
What you can't do is make them both negative,
Yeah, because then it'd be wrong.
because then it would become a positive.
That's what I'm saying.
Okay? The deal is that you should only assign it to one of them.
Yes.
So, typically, though it wouldn't be right or wrong, my students just prefer to give it to the top.
Yeah.
Because that's where we tend to see it. It's what our calculator will work with. We don't really write a negative in a denominator. Okay, so if we go to graph this, we want to start at 3. Okay, and then from here, how are we going to rise negative 5?
Go down.
We're going to go down 5.
Yeah.
Okay, but this is a negative 5
Then you go
over a
2.
positive 2. Okay, you can always check because a line with negative slope should always be going downhill.